let's look at significant figures. This was a really confusing thing to me when I first learned about it, so hang in there, and if it is strange and confusing, just kind of go with it as rules, a little game you're playing, and it will click the more that you do it. So first of all, significant figures is kind of an unfortunate term because figures is not really what we're looking at. It's digits. So when we say significant figures, the figures is really meaning like digits. That would make more sense, significant digits. Like this number has 2 digits, and so we're going to be talking about how to look at those. Anyway, we also abbreviate it a lot. Instead of saying significant figures, a lot of times we say Sig Figs, or abbreviate it SF, so Sig Figs. Anyway, the purpose of Sig Figs is that in science, when we say numbers, we want to say not only what the value is, like 25, but we want to indicate how well that number is known, how much error that number might have. So like if you have a measurement of 25 milliliters versus 25.000 milliliters, this one's much more exact, and this would take a much fancier instrument to get. And so again, we show not just the value, but how much error that number might have. And to see how this is applied, we need to start with our little rules about how to count and then how to handle them. And in the end, we'll be deciding how to round off our answers when we do calculations. So the first thing, let's learn how to count significant figures. So if you're given a number, we need to be able to look at it and say which digits are significant and which digits do not count as significant figures. So the first thing is, on this number, any zeros that are in the front of the number, these leading zeros, are never Sig Figs. Those are not significant digits. Okay. Anything that's not a zero or is sandwiched between non-zero digits always counts as a Sig Fig. So non-zero, like the 5 and the 2, and sandwich zeros, they count as Sig Figs. So we have four significant figures there, 4 significant digits right there. Okay, and then we have also ending zeros. Ending zeros count if a decimal point is shown. And I really emphasize the word shown because sometimes people say ending zeros count if the number has a decimal point. It doesn't just have to like imply one. It has to actually see, you actually have to see the dot for this to count. And so in this particular number, these zeros do count as significant figures because we do see a decimal point over here. So this number has 6 Sig Figs. It has these that are sandwiched and non-zero, and then the ending ones count because the decimal point is shown. And so what I'm talking about, if the decimal point isn't shown, for example, in a number like 100, written like this, these zeros are ending, but there's no dot, so they don't count. On this number, we would have just 1 Sig Fig, and I'm going to indicate that by putting a line over it. Sometimes we do, to kind of keep track, we put lines over or under numbers to say, oh, those are significant figures. Okay, but if I take this 100 and I put a dot right there, that changes everything. Now all three of those are significant. Okay, let's look at some examples. And I'm just going to write all the examples so you can get ahead of me on deciding how many they have. Okay, and I'm going to draw the lines over to show which ones are significant figures. So that's our goal here. So we're not only going to count them, we're going to say which ones. But anyway, so first one, very easy. These are all non-zero, so all of them are significant figures. Next one, non-zero are always significant figures, and these are sandwich zeros, so all of these count as sig figs. Next one, these are leading zeros, and it doesn't matter where the decimal point is. Anything on the left of the non-zero don't count as sig figs, so these two count. Again, on this one, all of these zeros here at the front don't count. They are leading zeros. This one is a sandwich zero, so it counts. So we've got 3 there. Again, a leading zero, don't ignore it. It's not a sig fig. Now we have an ending zero. Ending zeros count if a decimal place is shown. So we actually see the decimal point, the dot. So this one does count. Okay, and again, this is non-zero digits, and we have some sandwich zeros count. Here's some ending zeros, but no dot is shown, so they don't count. There's only one sig fig there. Here, this one has the dot, so that makes all of these ending zeros significant. And then on this one, when they're in scientific notation, all you do is you look at the front part. You can literally just kind of ignore this part for sig figs, just for sig figs, and assess this number like you would. And this is an ending zero, but a decimal point is shown, so all 3 of those are significant. And you may have asked, like when you look at these two, I can have either 1 sig fig or 3, but what if I had the number 200 and I wanted to write it with 2 sig figs? I could do that by putting it in scientific notation.